Hello, welcome to Enlightning. I'm here today with Anish Ramshaker, who's a maintainer on the Secrets Store CSI Driver. Tell us about yourself, Anish.
Hey, Whitney. Thank you for having me. Hey, everyone. My name is Anish Ramshaker. I'm a software engineer at Microsoft. I'm one of the maintainers for the Secret Store CSI Driver. I live in Redmond, Washington.
Excellent. So for enlightening in general, sometimes I already know folks in a certain space and then I just invite my friend onto the show. It's a very scientific process. But sometimes I don't know anyone who knows about a certain technology. And in that case, I put a very nice message in. I find this Slack either channel or the Slack workspace where people seem to be actively talking about a project. And I'm like, hi, will you please be on my show? And Anish is the one who answered my message. So Anish, so the point I guess is we're here today, two friendly people, one who knows a lot about something, one who knows almost nothing about that same thing. But it's really cool to get to know you through this way. And I'd love to hear more about your career path and how you came to be working on CSI Driver.
Yeah, of course. So I am basically from India. So I moved to US in about 2014 to do my master's in North Carolina State University. Right
Cool.
out of college, I started working at IBM, focusing on Kubernetes. I worked there for about 2 years, and then I joined Microsoft in 2019 to
Ah.
work on this super awesome team called the Azure Container Upstream team. The
Mm-hmm.
charter of our team is to primarily work on open source projects, CNCF. So I work on Kubernetes and other projects related to Kubernetes. So right about 2019, I started working on the Secret Store CSI driver, started contributing to it, and then basically adding features, working with the sig-auth community and other folks in the Kubernetes community.
So you're working on it as part of your day job?
Yes,
Okay, cool.
that's really cool.
Mm-hmm.
Yeah. So we do work on the open source projects, and then we also work on integrations of these projects with our Kubernetes platform, Azure Kubernetes Service. Um, and in terms of Secret Store CSI Driver, in addition to us folks from Microsoft, there are also folks from Google, HashiCorp Vault, who we work together with.
Cool. I love open source.
Oh yeah,
I just think it's such a I'm on the older side. I'm 44 years old, and I just couldn't imagine a world where different companies collaborate so much as they do in the open source community, and I just think that's super fun. And
yeah,
yeah, and also, well, not only do you just make friends across the entire space, but then it also maybe doesn't lock you into, in terms of your own personal knowledge, it
mhm,
doesn't lock you into a certain implementation if you ever wanted to learn and expand and work for another company or open source is also, I think, a cool way to get your foot in the door if you want to be able to work, eventually be paid like you are to contribute to open source. You can
yeah,
start just by doing it, and then if you do a good job for long enough and people see you, eventually someone will pay you to do it.
yeah, for sure. Like, well, I think that's how I started. Like, I started off contributing to some of the open source stuff on my own
Uh-huh.
because that was something that interested me. And then I was very lucky to land a job in Microsoft, ending up doing open source as my main job. So
Yeah, it's so cool. I see some folks are watching. I can tell by the little number icon I can see. Will you all say hello, please, and where you're from if you want to? No pressure, but we'd love to hear. I think I'm going to move on back behind the light board and get this show on the road. But while I do that, I'm going to share a couple links. And then I don't want you to get into the juicy CSI driver stuff until I'm behind the light board and can record it properly. But I would like to hear like what you're working on in general. Yeah, what's a day in the life of Anish like? And before I do, let's say hello to Alan. Hi, thanks for joining us today. Yay. All right, tell us about a day in the life, Anish.
Right now, I'm primarily working with the Kubernetes sig-auth community on some of the features.
The
Uh,
SIG docs community?
sig-auth.
Oh, SIG auth community. Got it.
So
Thanks.
I think in the previous year, we started working on this encryption at rest, which has existed before. So there was a V1 API of it, and a few folks in the SIG-auth community. And as for Microsoft, we've been working together to enhance the API in terms of providing better performance and observability. So like that was something that we've been focusing on. And
Can you hear me? Okay.
yes, yeah. So we've been focusing on that, and then we were working on the V2 API, which is beta now. In addition to that, we've also been focusing in other areas. So we've been looking at Auth Auth. So we're working on this really cool Kubernetes enhancement proposal right now called structured authentication config, which will allow users to configure multiple authenticators that they want to use with their cluster. So
Oh.
we have merged in the last release, and then right now we're working on the implementation. And most of the work that we do is driven by the Kubernetes release timelines. Some of the work we couldn't land in the last release, which is what we're working towards in the next one now.
So so is it like a project so your authentication with the cluster, like different authentication providers, are you working on a way to standardize that? Is that what I heard?
So today, Kubernetes API server, there are flags that you can use to configure a single JOT authenticator, but there's no option to configure like a list of authenticators, or there's no structured way to do it. So every time you have to configure, you basically have to go set up these flags, and then your API server restarts. So all of that, right?
Okay.
So we took some of the learnings from the encryption at rest feature, which has this file called encryption config. So it's more structured, where you configure which providers you want to use, what resources you want to encrypt. So similar to that, we're basically introducing a file-based approach where you can define a config using the YAML, and then you configure your API server to just look at the YAML and do all the configuration for the authenticators.
Nice. That's declarative, and it's so I'm pretty new to tech. I started in 2019, actually at IBM, so I must have like been arriving as you were leaving.
Yeah.
And so I guess I don't have a ton of context, but what's interesting is as I've been paying attention to Kubernetes, and I think this is what they mean when they say a technology is maturing. Like all these things you kind of do. Like I just went through a series learning about all the different CNCF Ingress projects and learning about Gateway API and how like a lot of stuff was just done through the annotations, kind of ad hoc, kind of unstructured to try to add this stuff. And now as the Kubernetes is maturing, every project seems to have a way to be like, hey, we can be more declarative and more deliberate and structured about this than what we're making up right now. So
Yeah.
it's cool to see that in different spaces.
Yeah, and I think it's really nice that we're able to learn from different features, like the things that work better, and then we're able to gauge how things are easier to configure based on feedback from other features, right? So like I think that's really nice too.
Yeah. All right. Look at us. We're doing the thing.
Yes.
Let me get back to comments. So those of you watching, what current what are you doing to manage your secrets in Kubernetes? Because that's pretty much a very early problem in Kubernetes adoption that you need to be solving pretty immediately. So I'm guessing a lot of you watching today probably have tried something. So give me a little context about, please, if you want to share. And if not, that's okay too. Anish and I have this. So Anish, how I love to start this part of the show is because I'm newer, I love to have a picture of what the world was like before your technology existed. So tell me, at a lands before a CSI, Secret Store CSI Driver, what was the problem? And we have a comment here from Olaf. Olaf uses external vaults. So
Right.
is external, I'm so clueless. I'm going to ask a lot of silly questions today. Is that a project, or is that, like, generally speaking, like HashiCorp Vault is an external vault? Or is external vault like a thing on its own?
I think so. It could be the so HashiCorp Vault is what I would think of over here, and
Yeah.
then they also have some integrations with Kubernetes, like different ways of consuming HashiCorp Vault. You deploy
Uh-huh.
the backend in the cluster, but then in the way you want to consume it, if you don't directly want to call APIs, they offer different solutions, and they're also one of the providers for our CSI driver. Just not to jump the gun for.
All right, tell us about the problem that CSI Secret Store CSI Driver is
Yeah.
solving.
So from my perspective, Kubernetes has this thing called Kubernetes secrets, right? But
Mm-hmm.
these secret objects, so they are API resources, it's core V1 API, but these secrets are not really secret. And
Yeah.
that is because anything you put in there is basically base64 encoded and then just stored in etcd. So anyone who has access to the cluster can basically read all of the contents that's there in the secret.
Mm-hmm.
Or if they have access to etcd, they can basically just loop through all the fields in the secrets and then they can read that. So there's no secret basically within the cluster. um,
Mm-hmm.
and the other thing is, it's possible you as a company or you as a user have standardized on certain third-party secret solutions that you want to use, and you're basically moving your applications to Kubernetes. So the question is, how do I consume these secrets that have already been set up in my third-party secret solutions? So that was one of the problems.
All right. So third-party secret solutions are already being used before Kubernetes is adopted.
Right. So, like, if they already have their applications running somewhere and then they want to move that into Kubernetes, but they still want to be able to use these third-party secret solutions.
Yeah, that makes so much sense.
And in addition to that, so like the third-party secret solutions also offer these auto rotation features, right? So, like, for good security hygiene, they can basically, you can set up certificates or keys, all of these to be rotated on a schedule. So you
Mm-hmm.
also want to be able to leverage that in your Kubernetes cluster for a security hygiene.
I haven't heard the term security hygiene before. I like it. I don't know how to spell it. Gen. I know there's an I in there. And hygiene, There, that feels good. Good security hygiene calls for secret rotation,
Right. And I
which
think
doesn't.
one of the other points that I can usually think of is, if you're working for a large company and let's say they've already invested in some kind of auditing and alerting to like basically see who's accessing the secret, and then if a secret has been compromised. So you already have these security information, even management integrations that you want to make use of.
In
Auditing and alerting.
auditing and alerting and management.
Yeah.
Uh, it. Oh, dang, I missed it. I'm moving too fast for my own good. Auditing, alerting, management. Cool. Of secrets. So this all makes a lot of sense to me. And
Mhm.
if anyone in chat has something to add, we'd love to hear it. But So I could group this into two categories. It could be two of these are like problems with the native Kubernetes
Mhm.
secret. So the basic C4 coded and stored in etcd isn't so not so secret. It's like when you tell a friend who you know has a big mouth. And then the there's no secret rotation as part of Kubernetes at all. So those are just like shortcomings with what the existing solution. And then the other two would just be a lot of companies aren't are moving into Kubernetes and they have a lot of existing stuff already and they want to be able to integrate what they're already using.
Right.
Excellent. All
Yeah.
right. So before we get any further along, what I would love is like a definition of what Secret Store CSI Driver is. But before Secret Store CSI Driver, maybe just a definition of what a CSI driver is, and then the Secret Store CSI Driver.
Sure. Um,
Okay.
so CSI stands for Container Storage Interface. And CSI is basically a standard to unify the interface between container orchestrators, like Kubernetes,
Uh-huh.
and different storage vendors. So basically, it's a common interface that every storage vendor can implement. And then having an interface defined here, it makes sure that the implementation would work for any orchestrator that supports CSI.
CSI. Okay, you just said so much and I just caught so little.
Yeah.
CSI is a standard interface between what two things?
To unify so it's a standard to unify interface between container orchestrators and storage vendors.
Okay. So not even Kubernetes specific necessarily.
Not necessarily. So any orchestrator that supports CSI, and if you implement it once, you can basically use it with any other orchestrator.
Fascinating. And external storage vendors, right?
Right.
Lovely. All right. And so now, what we all came for today, what is the Secret Store CSI driver?
Yeah. So before I jump into that, just to give a little bit of context, right? Like before CSI, basically there was this thing called flex volume that was in Kubernetes. So you would
Mm-hmm.
basically implement a volume plugin. And the way it would work was you basically put the binary into the host. And every time you need some volume operation, that binary was invoked. And then that's how the volume attachment would work, right? And
When you say host, do you mean like a worker machine? Okay,
yeah.
thank you.
So whichever worker node you want the volume operation to be done, basically
Mm-hmm.
you would just go and drop this binary. So it was all packaged as part of your worker node. And
Okay.
whenever there's a volume mount request, this binary was invoked, and then the volume mount, whatever operations need to be done on the cloud provider side was done, and all of that, right? And then also a lot of the volume plugins were pretty tightly tied to the Kubernetes code base. So all of it was in pre, which means
Mm-hmm.
anything that you had to develop was tied to Kubernetes development. You had to make sure that whatever you developed worked for different versions of Kubernetes because there was no like standard interface. So if something changed in the next Kubernetes version, you had to go and implement it and change all of it to work with that.
Okay. Yeah.
And the reason I mentioned this context is because before CSI Driver existed, there was this other solution that we had called Azure Key Vault Flex Volume.
Uh-huh.
So that was the origin that led to CSI Driver.
Okay.
So Flex Volume worked similar to the Secret Store CSI Driver, but it used the Flex Volume technology that existed. And
Uh-huh.
we eventually deprecated it and then moved to Secret Store CSI Driver.
Okay. Do you
And
think I should be writing any of this down?
not the Flex Volume. I just wanted to
Okay.
set a little bit of context here.
Okay. And
Yeah.
this is a very silly question, and I think I know the answer, but just I want to ask, when an application is using storage, is that storage always on a separate machine? It's accessing volumes from a separate machine, or is it reusing resources on the actual worker node
So
for storage?
once it lands on a worker node, that is where you basically use the resources.
Oh,
And
okay.
using persistent volume and persistent volume claims, you can
Uh-huh.
ask for like disks, and then there are like different types of volume mounts, right? There's like empty directory, like different type ones. But if you use
Uh-huh.
a disk, basically that disk is attached to the worker node that you land on,
Okay.
and that's
I think
persistent volume basically.
excellent. I've been doing this show. This is like the 55th episode. I think episode like 3 was how to add persistent volume to
Oh, wow.
Kubernetes. So hopefully you're paying attention a year and a half ago when we discussed it. Deshaun is here. Deshaun says, thank you for sharing that background information. Thank you for being here, Deshaun. It's always such a pleasure to see you, friend. Okay. So there was a solution called Flex Volume,
Mhm.
but it was not the best because every time a Kubernetes version got updated, the Flex Volume stuff also needed to be updated accordingly, and that was hard to maintain and high touch.
Right. And then also because it was a binary, it was just not easily deployable. And then there
Mm,
were like concerns around it, which is why eventually it got deprecated, not before was introduced. So coming back to CSI drivers, right? So I think
mm-hmm,
the CSI feature was added in about Kubernetes 1.15.
mm-hmm.
And a very small definition for the Secrets Store CSI driver is it basically uses CSI to integrate external Secret Store into Kubernetes.
Is a technology. Can I say it's a Kubernetes subproject, right?
It is. It's a
Okay,
Kubernetes sig-auth subproject.
I'm going to say that. Kubernetes sig-auth subproject. That, okay, what was the rest of it?
That integrates external secret stores into Kubernetes.
Cool. Into Kubernetes. Period.
Yeah.
Awesome. I want to put an exclamation point because that's just who I am in my heart. Hello. Simon is here. Thanks so much for being here. And Deshaun is impressed that episode 55. It's time flies, right? All right. So now we have all the context we need. And so I've been kind of driving the show with all my context and like definitions I've been wanting. But at this point, now that I have the base, the background knowledge, now I want you to tell me what's important to learn next.
Yeah. So if not CSI driver, I also want to mention like what options existed which drove us to CSI, right? So like I think we talked about before Secret Store CSI driver, what were the problems?
Uh-huh.
And then I think some of the alternative solutions, we could talk about it now or we could talk about it later. But if you want to jump into CSI, I think we should probably talk about the architecture, like about what are the things that get deployed into the cluster, what is the flow of events that happens.
Okay. I love it. So I'm gonna draw. This is like a Pictionary. I'm gonna draw a cluster, and you're gonna tell me what to put in there.
Sure.
And do I need control nodes and worker nodes?
You don't need control nodes, it's just worker nodes.
Okay. All right. What goes on my worker nodes?
So I think we would want to highlight the kubelet component, which
Okay.
we're already working on.
I like putting the kubelet like to show that it's helping. Do you think it should probably go on this side? Yeah? How do we feel about that? Cool.
Then I think we need a big box for a CSI driver because we need to put in 3 containers inside that pod.
Okay, so it's a pod?
So it's a daemon set that runs on every node, but there's
Okay.
one pod per node, and within that pod, there are 3 containers.
So this is a CSI driver pod?
Yeah.
How am I doing on real estate? Is there enough room for everything?
Yes, I think so. Yeah,
Okay.
I think it should be good.
And then we have 3 containers. Cool.
Yeah, I think we probably need the acronyms for the container names because they won't fit in.
Can I write the full name out here, or do I need the space for something else?
So you need space for the provider pod.
Okay.
Runs alongside.
Okay. Provider pod.
Probably one pod to show the actual application, which could be any one.
Cool. I got it.
So yeah, in the driver pod, the first container is called a node driver registrar, which we can just call it as NDR for now.
NDR. And then I'm just gonna put a little star. And what is it?
Node driver registrar.
Node driver registrar. We have a couple comments. We have, what is the tool for the screenwriter? This is called a light board. I got it from a company called Revolution Lightboards. It's very large and takes up a whole room of my house. And Simon's, it's hard to believe it's been a year. Yeah, it's been like a year and a half. We started in February. So time flies. And it's cool to have you here all this time. Thank you, Simon. All right, node driver registrar. Do you want to maybe tell me what it is before we move on to the next container?
Sure. So the node driver registrar is a sidecar container that's offered by the Kubernetes CSI community. And the primary function of it is to basically call into your CSI container, like your Secrets Store. So that'll be Secrets Store, but it calls into your sidecar container, your container, to get metadata about the driver, and it uses that metadata to register your driver with Kubelet. So it's 2 functionalities. One is call into your driver.
Okay, so one of these containers is the driver.
Yes.
Okay, that's what I'm a little, okay. Calls into the driver. Okay.
To get metadata about the driver.
Okay. Got it.
And then
registers the driver with the kubelet.
Perfect.
Cool. Excellent.
Yeah, so it's a very small functionality container, and this is the only primary thing that it has to do. Basically, at startup, call the driver, get the metadata, register it with Kubelet, and then just say, hey, I registered it, I'm all good. And the second one is basically, in our deployments, we call it the Secret Store container.
Secret Store container.
So I think we can just call it SS.
Okay, is that what you do in the community?
I personally do that, but
and Secret Store container. Okay, and what's that one do?
So this is basically the container that does everything that needs to be done in from the start of a volume mount request all the way to talking to the provider and doing the mount. So on a high level, we can say this mounts the volume with secrets from external secret store.
And when you say volume, does that mean it's giving it to the worker node?
Right. So the CSI driver is based on the ephemeral volumes that's supported. So ephemeral volumes were added in Kubernetes 1.16. And the way we do it in the Secret Store CSI driver is we mount a temp-fs volume as part of the pod. And then we write all the secrets from your external secret store into that temp-fs volume mount.
Okay.
What this means is when the pod goes away, the volume goes away. So the life cycle of the volume is tied to your pod.
So if we draw, so this is like a temporary volume that's mounted to a worker, like an application pod.
Mm-hmm.
Is that correct?
Yep.
Okay. We'll label and talk more about that later, but so when we say the volume, we mean that.
Yes, that's good.
Cool.
And that mounts the volume with secrets from the secret store.
Yeah.
Yeah, and we can go in depth and talk about like how the whole flow of events work. But like right now, I think architecturally this is it. And then the third container is called a liveness probe container. So it's just LP, liveness probe.
And then likeness, L-I-K-E-N-E-S-S?
Liveness, L-I-V-E-N-E-S-S.
L-I-D-E-N-E-S.
V-E.
Liveness. Got it.
Yeah.
It's still how perfectly trusting I am. Like liveness, I've never heard of such a thing, but if you say so, I'm going to go with it. Liveness container. Pod container.
Liveness probe.
Probe, of course. Probe container. Yeah. And whose liveness is it probing exactly?
The secret store containers. So it's basically checking that the driver container is running and it's healthy.
Which one? Both of the other containers?
No, just the second one, the secret store.
Okay.
And also this is one of the sidecar containers that is produced by the Kubernetes CSI community. So the first and the third one is not something that we maintain. It's part of Kubernetes CSI.
Mm-hmm.
The second one is the only container that we actively develop and maintain, which is part of the Secrets Store CSI Driver project.
And who does the other two, did you say?
The Kubernetes CSI community. So it's part of storage.
Got it. Cool. So any CSI solution is going to have the liveness probe and the driver register.
That's right.
That makes sense. Interesting. I love this. Okay.
And now we have one more pod, which is called the provider pod. So it's the CSI provider pod.
Workload pod or app pod? What do you think I should call workload pod?
Yeah.
And then TMPFS is like temporary file system volume. TMPFS. Temporary file system volume. All right.
So the provider pod is the one that basically does access control. So basically checks if the identity that the pod is referring to is allowed to access the secret. So basically access control. And second thing is it gets the secrets from external secret store.
And all in one container, since we're
all just one container.
access control and gets this
secrets from the external secret store.
Ah. So I want to draw an external secret store. Maybe it should look like a database, but I always feel like they should look like a vault.
Yeah, in one of our architecture diagrams, we have a big key, and that's just called external secret store.
There you go. So, so basically this is talking to this.
Right.
Cool. And then workload pod just has workloads, one or many workloads, probably just one.
Right.
Yeah. And then that workload has access to secrets.
In the file system, that's right.
In the file system. I drew a little key. Yay, secrets. All right. This is beautiful.
Yes.
I'm happy with this. Yeah. So so from here, do you feel like we captured everything that's part of the architecture?
Yes.
And do you think are there any improvements that I can make that you would like to see to more accurately represent what's happening?
No, I think it looks good.
Wonderful. So then I think I'm interested in, now that we have this, the linear workflow of what happens. Unless there's something you think is more important to teach right now, which if that's the case, I'm all for it.
I mean, I think on a very high level, if we have to talk about how the whole orchestration, like the flow works with this, it's basically when a pod has, I think we also have to dig into like the custom resources that we have, but which is used to configure the vault to use and all of that, right? But before we go into that, on a high level, let's say you create a pod which has a volume saying, hey, I want this volume and I want this volume to be mounted by Secrets Store CSI Driver. So in the YAML spec, you can basically say which driver should mount the volume. And when such a pod gets created, basically kubelet calls into the Secrets Store container. So that's the first.
Okay, I'm gonna hello. So first the pod gets created, pod with secret volume.
Yes.
Gets created. And then somebody sees it happen.
Kubelet on the worker node will see it. So kubelet will call the CSI driver, the secret store container.
Got it.
And at that point, the secret store container mounts the tempfs volume.
And at that point, is the volume empty of secrets, or does it already have the secret in it?
No, it's still empty.
Okay. Cool.
Then the secret store container calls the provider and says, hey, go get me everything. Get me all the secrets.
Calls the provider.
Yes.
I'm just gonna use all the same terminology as what I wrote up there because that's how things stay clear. CSI provider pod.
Mm-hmm.
To get the secret from the external secret store.
Right.
Cool.
And the external secret, the CSI provider pod gets it and sends the secrets back to the secret store container.
CSI provider pod. Oof. Okay. Provider. Get secret from external secret store. We're just going to say store. No, I can't do it. And gives the secret to the secret store container. Cool.
And at this point, the last step, secret store container writes it and says, we are good to kubelet.
Writes it into the temporary file system of the pod?
Yes.
Love it. I'm glad it's not longer because I was running out of space. Store container. Writes the secret. To the temporary file system volume mounted to the workload pod.
Yeah.
Voila! Chef's kiss. I love it. I'm writing chef's kiss. Cool. Awesome. That's so great.
Yeah, that looks really good. I think I just have to replace my architecture diagram with this one in the
Wonderful. Okay, I love this. Excellent. So we have some space. What do you want to teach us next?
So these are all the components that get deployed, what happens in the flow of events, right? But you as a user, how do you configure which provider to talk to and which vault in that provider? So basically, how do you provide all the provider properties, like in terms of identity and all of that? So we have this custom resource for that.
How does a user configure all of this?
Mm-hmm.
Did I stay on screen? Okay, great.
So
and you said some custom resources.
Yeah, so we have two of them, but only one of it is user configured. The other one is mostly for status, so we can talk about that. The first one is called a secret provider class.
Secret provider class.
Yeah.
Excellent.
Yeah. So in terms of the schema for this, right, like the only thing that's really a concrete field is called the provider. So you as a user say which provider the CSI driver should talk to, because we basically support multiple providers, right? So there's a provider field where you say which provider you want to talk to.
And when you say provider, do you mean Secret Store or do you mean provider pod?
So it's just the provider name. So like today, the different provider names we support is like Azure, GCP, AWS, and all of that. So it's a key value, right? So it's just a name where you say which provider we should talk to. So that will be the CSI provider pod's name. Like not exactly the pod name, but it's just a provider name. So basically, this provider name is what the Secret Store container uses to know which provider pod to talk to.
Okay. It's the CSI provider pod.
Yeah. And I mean, if we have to go into the details, right? So basically, this provider name is equivalent to the socket name, because we use gRPC between the Secret Store container and the provider pod. So this name is basically the socket name.
Okay.
We use that name and we construct the socket path, and then we just talk about that path to whichever provider is listening. So it could be any CSI provider pod listening on it.
So it's not like a one. I understand it's not a one-to-one, but in terms of just trying to relate this back to the architectural diagram, that's what makes me want to be a little more specific. But I mean, we're using the word provider, so I feel pretty good about it. Deshaun has a question. Is Vault an option for providers? I guess you mean HashiCorp Vault. Is there other vaults like Vault? HashiCorp really dominated.
I think HashiCorp Vault. So like, give a very brief history, right? Like, so the Azure Key Vault provider and HashiCorp Vault were the first two providers for this project. And then now we have expanded to GCP, AWS Secrets Manager, and then we also have like few more providers in the pipeline.
Vault, GCP. Can I just say AWS or should I say AWS Secrets Manager?
I mean, just AWS is fine. And then Azure.
Okay. Azure.
Yeah, and in terms of architecture, you always just need a single instance of the CSI driver running. So basically, just one daemon set. But different providers have their own daemon set. So like if you have like 3 providers that you want to use in your cluster, you would just have 3 CSI provider pod. One for Azure, one for Vault, one for GCP.
So this and this both run as daemon sets.
Yeah, both of them are daemon sets. So you need one pod of each on every node, because the mount operation happens in the node, in the single node, and all the communication is through Unix domain socket. That
makes sense, because the secrets are being stored only on that node and no other node, not on any nodes that don't need them. Thendal's here. Hi, Thendal. It's been a while. It's true. I'm so glad to have you. I hope you're doing wonderful, friend, and I hope Zelda's great. Zelda's Thendal's cat, and it's very, very cute cat. Okay, so the secret provider class, you have to specify the provider for sure, and then it sounds like that's the only required field.
So that's a required field, and then there's this field called parameters, which is an opaque field. So basically, that parameters, the schema of it is defined by every provider. Like the driver doesn't mandate it.
Okay. So they're provider specific.
Yeah. So each provider can, so like talking about the Azure Key Vault provider, right? So basically we get the Key Vault name, the name of the identity that should be used to access this Key Vault. And then there's like a array of secrets that you want to get. So you can say like, hey, I want to get secret 1, secret 2, certificate 1, certificate 2. Basically you define all of those, but it's provider specific.
So examples would be which secrets to get?
Yeah, which secrets, which backend name. So which external secret store name?
Which, okay.
Yeah, if you have multiple instances. So.
And then Deshaun has another question. CredHub. Does CredHub work?
I don't think that they have a provider for it.
And then Deshaun says it seems there are only 4 supported providers, these 4. Is that correct?
Yeah. So just to clarify that part, right? So when we say supported providers, basically we have this criteria. So like I'll also share the link to the doc later with Whitney. But the idea is for a provider to be called supported provider, we do like code reviews of the provider. Like that was one of the things that we went through as becoming part of sig-auth sub-project. So like we really like that process. So we do that. And then we basically recommend having some basic E2E tests on our driver repo for that provider to make sure that we are not breaking anything in the driver for the provider. Like we are making sure the interface is intact and nothing is broken. So like we recommend adding those. So once you add these 2 things, you can become a supported provider and we would add you to the list.
So it's compatible maybe with other providers, but not supported.
Right.
Okay.
So the beauty of this is there are like lots of providers out there for CSI Driver. It's just that they haven't started the formal process of getting documented. But I think there's like a provider for every single option, most of the available options out there. And then we've also had like folks from companies reach out because they are developing in-house providers, which are not open sourced. But because the interface is generic enough, they're able to just develop their own provider and use it internally without work.
Cool. Great. Do you have more you want to say about a secret provider class custom resource?
No. So just the details of it is basically the pod that we talked about that has the volume. In the volume, all it does is it says, I want to use this secret provider class.
Okay. The volume.
Yeah, pod with secret. So in the flow, the first one, you have pod with secret volume. In that secret volume, there's just a reference to the secret provider class.
Okay.
And that is it. So basically, the driver will send all the parameters to the provider, and then the provider understands it, does what it needs to, and then returns the secret back.
And the volume is where it's referenced.
Yeah, the temp-fs one. But the secret provider class is referenced in the pod YAML. So basically, the pod says, so where the pod says, I want a volume with CSI driver, it also says, like, hey, use the secret provider class.
Okay.
So you know which provider you have to talk to.
We have a question from Olaf. What does supported mean in terms of open source software or in terms of this use case too?
So yeah, so this supported in at least from this context, it really means, hey, we as the driver maintainers and like everyone in the community have validated that the provider implementation works, and then we also have tests for we have test metrics to confirm that it is still working. So like one of the criteria is if the tests with the provider are failing for longer than 2 or 3 months, right? Then we would remove them from the supported provider list because we don't know if the current implementation of the provider still works with the driver. So basically, this is us just telling, hey, we know it works, you can go use it.
It's a stamp of approval.
Oh, no, I wouldn't go that far.
It's common for a specification to have tests. Like that's something we were talking about recently with Gateway API. Yeah.
I mean, it's basically tests to make sure that we don't break anything in the driver.
Yeah.
A non-backward compatible way. And then similarly, if providers are releasing, just to make sure that they are still compliant with our interface and they're not doing anything different. That is not in the scope of the project. Because we don't want providers developing their own different features which are not compatible with the driver, and then it becomes like a spin-off. So
Yeah. Cluster API does the same thing. They have third-party providers, and they have tests that you have to pass to be an official provider.
yeah.
Cool. What's next?
So there is one other custom resource, which
Okay.
is not something that users configure, but it's something that the driver uses as like a status resource. So that's called a secret provider class pod status.
Oh. Secret provider class status, or is there
Pod.
another word in there? Pod status.
Yeah, naming is hard, so.
It's true. Did that all stay on the board? Yes.
Yeah.
Excellent.
Yeah.
So humans do not configure this.
Yes. But it's human readable, so.
Okay. You can go on.
Yeah, so the basic idea for this custom resource is once we finish mounting the volume and writing the secrets, we basically populate this custom resource for that pod to say which all secrets are there in the volume and what versions are there right now. So it's basically just a status so users can go see, oh, I'm using this certificate, I have this secret from this vault and it's currently at this version.
Okay, so what are some example status fields?
So the secret name and then the version, like that's the most important ones basically. And so for the secret provider class pod status, it's not provider specific because this is controlled by the driver. So it has like a fixed schema.
Okay, so secret name and version, do you want to put any other example fields in there, or do you think that's...
That is pretty much it. So like today in pod status, we only have those two fields.
So there's, okay. Then I'm not going to put example because they're literally the only two status fields. Cool.
Yeah. On a high level, I think this is the whole set of things that you as a user configure, deploy, and what gets created.
So is this meant to be used like in tandem with other secret stores? How does this relate to external secret operator? It seems similar, but like a different approach to maybe the same problem. Right. Is that true?
That is true. So basically, ESO will sync the secrets from external secret store as Kubernetes secrets, right? And the CSI driver was started so that the secrets are available as in the file system instead of Kubernetes secret.
Okay.
But ironically, once we had the CSI driver, a lot of users wanted sync as Kubernetes secret. And we added that feature on top of this mount. But also, like, as a community, we are thinking about removing that feature from the driver and then making that just as a standalone project, or work with the ESO folks. So like they've been really receptive. We've been working closely with them on trying to find a way where we can have some interoperability and piggyback on some of the custom resources both of us have.
What would be the point of making it its own standalone thing when external secret operator already exists?
So the one is we already have a lot of users accustomed to like the provider class and like how things work, right? So that was one of the reasons that we were thinking about making a standalone thing.
Okay.
And we've been having discussions with the ESO community as well to see if there's any other way where current users of the sync feature can use ESO in a different way, basically.
Okay. So the big difference between this and CSO, external secrets operator, ESO, um, is is that ESO pulls from a secret store and stores as a Kubernetes secret.
Right.
When y'all pull as a secret store and use it as a temporary file system mounted to the pod.
Exactly.
And and then what are use cases for each one?
So the Kubernetes, okay, so like the context in terms of why we added sync as Kubernetes secret, right, was
Mm-hmm.
because most of the ingress controller implementations still expect the certificates to be provided as Kubernetes secret. So you configure
Mm,
TLS
mm,
cert and TLS key as a Kubernetes secret, and
mm-hmm.
basically you map that in your ingress resource saying, hey, this is a cert I want to use. And that does not work with search in the file system. So you need to provide it through Kubernetes secret. So that was the predominant use case for us to add
Mm-hmm.
the sync as
Uh,
feature.
uh-huh.
And on top of that, some of the users that I've seen today with using the sync, they also use the sync it as Kubernetes secret and then load that as environment variables from the Kubernetes secret.
Okay. And turns them into Kubernetes secrets. I have never written the word secret so many times in my life. Secrets Store CSI Driver. I like your episode title, like Keeping Secrets Secret, Secret Store CSI Driver. I also was feeling that way when I was writing provider over and over again. But that's okay. So and then this is Secret Store. And then we're running out of space, but what would you like to maybe put in the what do you think is a lot of how you want to spend the rest of the space? And also I can fit little things in around some more. So
Got it.
if you have more to say, I want you to express yourself.
Yeah. I mean, on the driver side, like some of the features that I would call out is one, it supports Linux and Windows, but maybe that's not uh, too, that doesn't need to be on the board. But I think one of it is so the driver uses the pod's identity to talk to external secret store.
The the driver uses the pod identity to do what?
To talk to basically get secrets from external secret store. So
Okay.
one of the things is typically with controllers and all of that, like you basically have to provide the controller an identity to say, like, if you have three vaults at the back end, right, like vault 1, vault 2, vault 3, you would,
Uh-huh.
if you have a single controller, you would say that controller can talk to vault 1, vault 2, vault 3. So it needs to have god level permissions on all the vaults so that
Uh,
get it and do whatever it needs to, right? But
uh-huh.
the best part about the CSI driver is you tie which vault has permissions to the workload part. So if my
Yeah.
workload only has access to vault 1, you basically have
Uh-huh.
an identity tied to it. The
That makes
driver
sense.
will act on behalf of the workload using the workload's identity and then just talk to vault 1. That's it.
Okay.
So I think the call out is we use the workload pod's identity.
I think I see it on the screen. Okay, so help me. Should I put that here, do you think?
Yeah, I think that, or I don't know if we'll have space on the other side though.
Mm, I can cover up where my face goes. I guess we'll use this space now, and then if we need to cover up my face. And I have a triangle's worth of space here too. Um, so the secret store container uses the workload pod identity.
Right.
to access the external secret store.
That's right.
The secret store container. Oh, we have a question too. Let's answer this. Is there any way to refill that temporary file system volume periodically, or is it only populated when it's created?
Yeah, so that's a great question, and I think we were going to touch on that too. So the CSI driver has this feature called auto rotation. So with the auto rotation, basically, the periodically we check if there are newer versions of a secret in external secret store, and if there are, we would refresh the volume mount with the newer secrets.
The Kubernetes control loop in action. Yeah.
Yeah. So the really nice part is today we have a control loop in the driver that performs this operation. So basically it runs periodically and checks if there's a newer version, and then if there is, then it updates the mount. But in a future release, we are actually going to piggyback on this requires republish volume feature in CSI spec, which means kubelet will call us periodically to say, hey, go check if you need to perform any action, and if you need to, just go up, do that. So we don't need to have the control loop in the driver. We can just rely on kubelet calling us every minute or so.
Nothing more. Am I still on the board?
Yeah.
Nothing. The secret store container uses workload pod identity to access the external secret store, so it only can access what that pod needs and nothing more.
Right.
Cool. And then did you want me to capture what you just said about the temporary file system being periodically synced, so it's always up to date?
Yeah, I think we can basically just say it supports auto rotation. So like periodically refreshes the contents from extra secret store.
Okay. So I'm going to write that, but is this maybe like a series of like additional features?
I think the major ones are rotation and this. Like and then I think we talked about sync is Kubernetes secret, but it's just a feature out there. But we're also trying to get away to a separate one.
Okay. So I can't start abbreviating your technology now at the very end.
Oh, so also in upstream, sometimes because the name is too long, we just call it SSCI.
SSCI?
Yeah.
Sounds like, yeah, definitely sounds like a sci-fi show. Also, does auto secret rotation?
Yeah.
Can store secrets as Kubernetes secrets?
Yes.
And then uses workload pod identity to access external secret store. Is there another way that I should say that?
No, I think that's a more apt way.
Cool. So if anyone has more questions, send them come in right now. If you have more you want to teach, we can write over my face. We can fit it in. And if you feel like you're wrapping up, the next step is for me to do a recap. I'm going to review everything you've taught me and make sure we're on the same page with everything.
Yeah, I think we've covered all the concepts for the CSI driver.
I love it. This has been really fun to learn about. And it's a cool technology and so necessary.
Yeah.
So if you feel ready, then I'm going to do a recap. Do you feel ready?
Yeah.
Okay. So before, long ago, in a time far away, before Secret Store Driver exists, there were two types of problems. One has to do with problems with the native Kubernetes secret object. So first of all, it's not a very secret. It's just base64 encoded and stored in etcd. And also, it doesn't have any security hygiene, which I love. It's not very clean. It's a dirty thing. It doesn't have good security hygiene, so you can't do secret rotation with it. So it doesn't happen with the native Kubernetes secret object. And then on the flip side of that, the problems have to do with companies adopting Kubernetes that maybe already have secrets solutions in place. So so they want to use the secret solution they already have. They don't want to create a new one just for Kubernetes. And so they're probably already invested in auditing, alerting, and managing secrets. And so they just want what they're already doing to become compatible with Kubernetes. And we have a question from Olaf. Does Secret Store CSI Driver provide an environment variables and file system objects, or is it just the temporary file system mount?
So the basic functionality is just the volume mount and writing it to the file system. But on top of that, like I mentioned, we added sync as Kubernetes feature because it was asked. And for environment variables, a lot of users, what they do is they sync as Kubernetes secret, and then they just reference that as environment variables. So there is no default way where the driver does it. And that is also one of the reasons why we are trying to move the sync secret out, because it's not exactly CSI. So like we want to keep the CSI functionality just for the CSI driver and nothing else.
Smart. So CSI, and part of the recap, CSI stands for Container Storage Interface. And CSI is a standard interface between container orchestrators, so Kubernetes, but other container orchestrators too, and external storage vendors. So HashiCorp Vault, probably Home Secrets. We have AWS, Azure, GCP, everybody has one. So Secrets Store CSI Driver, it is a Kubernetes sig-auth subproject that integrates external secret stores into Kubernetes. So specifically, it does that by integrating them into a temporary file system volume mount, although it can do Kubernetes secrets also. So then we talked about the architecture of CSI Driver. So on your works, we have a set of worker nodes here. So the CSI Driver pod and the CSI Provider pod, those run as daemon sets on each host machine, on each worker node, because you only ever want the secrets that are needed on that node to be on the node. So you don't want to have secrets from another node on this node. It's just bad. It's not hygienic, right? Did I do that right?
Yep.
So they run as daemon sets on every single host machine and every single worker node in your cluster. And the CSI driver pod has 3 different containers. So these containers are the node driver. Well, let's say 2 of them are specific to CSI. So they're not necessarily, they're just like any container storage interface will have these 2 containers. And one is a node driver registrar, which calls the CSI driver to get metadata about the driver and then registers the driver with the kubelet. And then also the liveness probe container, which checks that the secret store container is running and healthy. So every CSI solution is going to have both of those. Well, So then the secret store container is the one that's unique to Secret Store CSI driver. And it mounts the volume with the secrets from the secret store to the workload pod. And so that's what's going on in the CSI driver pod. Now there's also a CSI provider pod, and it does access control and it gets secrets from the external secret store. So when we say CSI provider, we mean external secret store providers. And so it's connected to the external secret store. And then of course we have our workload pod that needs access to secrets. And those secrets are mounted to the workload pod in a temporary file system volume. And so the flow of it is that the pod gets created, the pod that needs secrets gets created. And so the kubelet sees, hey, this pod needs secrets. CSI Driver pod, will you help us out, please? Specifically, Secret Store container, will you help us out, please? And the Secret Store's container is like, yeah, totally, I got you, and mounts a temporary file system, an empty one, to the pod. Then the Secret Store container calls the CSI provider and says, hey, I need your help. Will you please get the secrets from the external secret store? And the CSI provider pod's like, hell yes, I will. That's like why I exist. And then the pod pulls the secrets from the external secret store and then gives the secrets to the secret store container. And then the secret store container writes those secrets into the temporary file system that it created on the pod. And then the workload is like, yay, I have my secrets, and everybody's happy. That's the fairy tale. Was that accurate? Did I get all of that in my silliness? Yeah, okay. So that's how it all works. I love it. I love learning how things work. So then how does a user configure all of this? So there are two custom resources. I guess we should say, how does a user interact with all of this? I like that better because then it uses both resources. Interact with all of this. No, it's not very legible, but so there are two custom resources. There's a secret provider class. So that's good, how you're going to be able to tell CSI Driver about your external secret store. So you're going to which is called a provider. So you use this a secret provider class to specify which provider that you want, and it's common to have more than one provider for secret stores. So this isn't, so you can have more than one of these going at once. And then you're also going to specify provider specific parameters. So that's where you say like which secrets you want and what's the external secret store name. So there are some of these secret stores are supported, which means they've passed certain tests, but there are many that are compatible that don't have that supported label. So that's a secret provider class, and that's something a user will touch and configure directly. But then we also have a secret provider class pod status, which is humans do not interact with it. Well, I mean, they do in that they read it, but they don't write anything to it. So it gets populated by the pod to provide status. So and the status is happening in the workload pod itself. And so the status fields it's just like the secret name in the version. So it lets folks know what secret names and versions does this pod have access to. Sean says the summary needs to be clipped into a short hell yes. So then we got into some of the nitty gritty about it. So that it supports Linux and Windows. It also, a few weeks ago did an episode about External Secrets Operator. They're the ones who actually said, hey, you should do a Secrets Store CSI Driver episode. So you have those Lucas and Maritz to thank for this episode. But yeah. And so the difference, because this feels very familiar, not the flow, but the idea that like we're getting secrets from a driver and pulling them into external secret store, and pulling them into Kubernetes. But the way it's happening here is that once we get the secret into Kubernetes, it's mounted to a temporary file system volume. And the way the external secret operator, they do it, they pull it into Kubernetes and they make it into a Kubernetes secret. But as a side note, you're like, oh yeah, we can make Kubernetes secrets too, but I don't want to get into the nitty gritty of how your secret Kubernetes secret part is different from theirs. But but in terms of comparing those two technologies, that's the big difference. And then Secret Store Driver also does auto secret rotation, which I wouldn't have known what that meant, but you described it to me. So that means the temporary file system will sync automatically to make sure it always has the latest version of the secret, or if anything changes, it gets pulled in automatically. So you don't have to do any touch. There's no high touch there. And then it also can store secrets as Kubernetes secrets, as I just said. And then it uses workload pod identity to access the external secret store. So that way it only accesses what the pod needs from the external store and nothing more than that. And that's it. That's what we learned today. Do you feel good? Are you happy?
Yeah.
Okay. Awesome. Well, I think I maybe neglected to tell you this, but we're gonna say goodbye by putting the intro song back on and dancing a little bit. You cool with that? It's just
Yep.
your shoulders on the screen. You can move the shoulders, and we'll say goodbye. Thank you so much, Anish, for being here and for sharing your time and your expertise.
Yeah, of course. Thank you for
I
having me.
appreciate. Yeah, and thank you everyone for your wonderful questions. Thank you for watching. Thanks to everyone who watches the recording later. Yeah, let's do this. Let's dance it out. Bye. Oh, come on, Anish. Just give me a little shoulder, just a little bit.